Hello everyone, this is Ari from pantechelearning. So today we are going to see is we are going to develop the code for DMA using the UR. Okay. So I will create a project. So first thing we have to do is we have to select the board. Okay. So what is the board here? So this is the board we are going to use it. Okay. So as well as we have to give the core and device drive startup. Okay. So the first thing we have to do is we have to add the .c file. So the first thing is we have to add the startup file. Then what are the functions we are going to create? First, we will create a system clock configuration. So we have already developed in yesterday's session. So we will just make a copy of it. Okay. So first thing is this is already we have developed in the yesterday's class. If you want to see me, you can see this or you can refer the user video. Okay. So next is we are going to configure the init UART initialization. So void of void. So what is the first thing we are going to do? We have to enable the. So what is the register we are going to use this? Go to the AHB of APB1. So in this you can see we have an 18-bit as an USART enable, USART 3 enable. Okay. So we will create RCC of enable the USART 3. Okay. USART 3 enable. Now we have enabled the USART. Then we have to select the pin. So we have to give the clock, enable the clock to the GPIO. So we have to know which GPIO we have to see. Okay. So for that, we have to find the user 3's pin. So it will be in so of 3 means it will be of. So you can see PB11 as an pin. This pin as an user of RX 3 RX and 10 as an TX. Okay. So we are going to configure these pins in the port B. So we have to enable the clock for the port B. Okay. So it will be in the AHB one here now. So I will enable it RCC off. Enable. So now we have enabled the init. Okay. Next step is we have to go to the GPIO. In this we have to see the alternate function. So next is we have to select the alternate function for those pins. So we have a confidence USART of 3. It is in the 8 to 15 pins. It is because it is 10 and 11. So USART of 3 is 7. AF of 7. Alternate function 7. Okay. So go to the I register. So we have to send 1, 2, 7. So we have to send logic 7 to the 10th and 11th bit. So do the 8 and 12. Okay. So gonna go GP. Next is we have to select the model register. So we have to set the alternate function for 2 pins. Okay. So in this we have to select the pin as 10 and 11. So I have to send a logic 2 to 20 and 22. To the 20 and 22. So this will set my alternate function. Then next we have to enable the DMA. So for that go to the DMA register in this. So what are the registers we have? We will see it. So this is for interrupt. This will have an as from string 0 to 3. Then I register I interrupt status register as well from stream 4 to 7. So we have total of 7 streams in one DMA. So we have 2 DMAs, total of 14 streams. So this is for clearing those bits, interrupt flags. So we will see is streamx configuration register. So before this, we have to go to the user control register 1. We have an this control register. So in 2 we have a DMA. Okay. So we have in a control register 3 we have a DMA transfer enable and receiver enable. So first I will enable the transmitter. Okay. In which register it is. It is in a CR of 3. Okay. I'm going to enable the transmitter. So 7th. On the flip of 7. So this will enable my DMA. Okay. DMA transmit. Then next step is we have to set the border. So we have already derived the value for 16 megahertz. My clock is running in 16 megahertz. So you sort of 3 VRR is equal to 0 cross of 0683. This will set. This is a baud rate for 9600 at 16 megahertz of frequency. Then what is the next step we have to do? We have to enable the TE and RE. So go to the CR1. So we have a TE bit and receiver bit in the 2 and 3. So now we are going to just transmit. So we will enable this bit third bit. Okay. So you sort of so this will enable my TE. So we will cross check as third bit. So 1 left shift to 3. Sorry, it is 7. So this will enable my T. Finally, we have to enable the user in 13th bit. So we have to so we will send this logic one to of 13. So this will enable my UE user enable. What is the final thing I have to do? I have to enable the interrupts. Okay. So for that, go to the so I'm going to enable this TXE. So I'm going to transmit it. So I'm going to enable this 7th bit alone for interrupt. Okay. So I will send logic. So this will enable my TXE. Now we have init step is finished. Okay. So next is so next is we have to create the right function which we have already created in the USART. Same thing. Okay. Then now we are going to create a DMA init function. Okay. So void of so what is the first thing we have to enable the clock for the go to the so go to the RCC of HB1 register ENR. In this you can see we have a DMA of 2 and DMA of 1 enable. So before this we have to know in which stream and channel it is connected. Okay. So go to the DMA information. So what is the thing we are going to configure is we are going to configure is USART of 3 of TX. So it is in the fourth channel stream of 3. So we have to specify this stream. So it is in the DMA 1. So go to we have to enable the DMA 1. So we have to send logic 1 to the 21st bit in HBE. So RCC of HB1 on left shift of 21. So this will enable my DMA. So next thing, what is the next thing we have to give is we are going to so next thing is we have to say the from memory direction, right? So go to the DMA registers. Then just go to the control register. So we have a control register here. Okay. So what is the first thing we have to say is we have to say the direction. So what is the direction I am going to read? So I am going to read it from the memory. So memory to the peripheral. So peripheral which denotes the user and memory which denotes the my microcontroller's memory. So what is the long-term processes? I'm going to store the ADC value in the memory. Then I'm going to take the value from the memory to peripheral. So peripheral to memory and memory to peripheral. So first peripheral is ADC. So ADC to memory. Then it is going to memory from the user. Okay. So I have to set the direction first. So we have one direction bit is. So we have a 6th and 7th as a direction bit. So what is the first thing we are going to do is we are going to send it from memory to peripheral. So memory to user. So what is the first thing I have to do? I have to send the logic one to the 6th bit. Okay. So how to denote it is DMA of 1 in that which is the stream of 3 because so you can see we have a user 3 of tx in the stream of 3. Okay. So not we are going to not we are not going to fill Rx because we are not going to get the value. We are going to transmit the value from the memory to the serial monitor. So it is in the string 3 channel of 4. Okay. So you have to mention the string. So stream of 3. In stream of 3, which is the register, it is control register. So on left shift of 6. So this will set my direction from memory to peripheral. So what is the next thing I have to do is now I have to select the circular mode, memory increment, and I have to say the peripheral size and memory size. Okay, so these are things I am going to do. So we will go to the register back. So you can this is we have a 0th bit as an enable stream enable. We will concentrate on we will finally enable it. So we have to send the logic one to the 8th bit. So the peripheral increment is doesn't need it. So we will so we have to enable this peripheral increment mode also because we are giving the data for this is peripheral increment mode is for from peripheral to memory. Now we are taking the value from memory to peripheral, right? So we will not configure this. So we will send logic one to the circular mode. Then we will add a memory increment. Okay. So we will set the bits logic one in these bits. Okay. So then next thing we have to say is p size and m size. What is the peripheral size and what is my memory size? I'm going to set this as an 8-bit because my user is going to read and write the data in the 8-bit of word. So I'm going to set it in the 8-bit form. So then we have to say what is the channel we are using. So what is the channel we are using? Channel is 4. So we have to say the channel 4. Okay. Okay, we will now set this things. Okay. So first thing we have to do is DMA of 1 stream of 3 in the control register. So first thing I have to tune on the circular. So I will send it to the logic. Then I have to set the logic 1 to the memory increment. So I will set the DMA of 1, stream of 3. So first I am going to set a 0 in these bits for the memory size and the peripheral size. So first is peripheral size and send the 3 to the 11th bit. So this will set my P size, peripheral size. Then I have to do the memory size. So I am going to set those bits also as an serial shift of 30. So now I have set the. So then what is the one thing we left is we have to set this bit also. So peripheral increment bit also. Okay. So we will set those bit also. So it is in the ninth bit. So ninth bit. This for peripheral increment. Okay. So next is we have to say the priority level. So we can use lots of streams at the same time. So we have to choose what is the priority for the streams. So you can see we have a priority level. So we will set this as a 0. So I will left shift the 0 to this 16th bit. Okay. So DMA of 1, stream of 3 is that. To give us CR of left shift of 60. This will set my priority in the low because we are not using other streams. So what is the final thing is we have to select the channel. So what is the channel we are using is fourth channel, right? Channel 4. So because we have RX TX in the fourth channel of stream 3. So what is this fourth channel? We have to send the logic 1 to 4. So we have to send logic 4 to the 25th bit. So we will send the DMA of 1 stream 3 in that CR control register. I will send the 4 to the 25th bit. So this will select my channel 4. So now we have already created the DMA init function. Okay. So what is the next thing we have to do is next thing is we're going to create a DMA config. Okay. So void of we will name it as DMA. So what is it int of? So we are going to send our address source address in the 32-bit offline. Okay. So 32-bit address. So it will be source address. Then it is also going to be a destination address. Then finally we are going to give a size. Okay. So now we are created. So what is the thing we have to do? We will go to the register first. This we have a number of data registers. So this in this register we are going to say the size. What is the size of the data we are sending? Okay. So next is we are going to send the peripheral address here. Peripheral address means it is the address of my user. Then I am going to send the address. So this is the memory address. Okay. So we will set this here. Okay. So DMA of one stream of three. In stream of three. So DTR. DTR. I'm going to give the size. So next is again going to be a DMA. This I am going to say the peripheral address. Okay. What is my peripheral address here? It is my peripheral address is USART address. Okay. So I'm going to take the data from the memory, right? So this is the my peripheral address is the destination address. Okay. So next is DMA of one in that stream of three. In that next is memory. So we are not using double buffer, so we will use the memory 0 row register. Okay. So in this, from here only we are going to take the. So from here only we are going to take the value to the peripheral. So we are going to see the value from the monitor, right? Serial monitor, right? So this is where the source address is. Source address. So what is the final step we have to do? We have to send the logic 1 to the 0 the bit in the control register. Why? Because we have a start stream enable stream here. Okay, in the control register. So DMA of 1. That I'm going to control register and left shift of 0. So this will enable my stream. Okay. So now we have created the DMA config. Okay. So next is so next is we are going to create a int main function. Okay. So before that, so before that we will so before that guys, you can now convert this masterclass into an internship. So like this, while developing code, these are the things we are developing. So if you have any doubts later, this codes means you can use this internship for the upskilling yourself. You can ask me directly questions, and I will be helping you for developing the projects or the errors in the codes. So we are going to develop. We are going to add some lots of contents in the internship classes. So guys, you can use this opportunity to upskill yourself. So our fees is 1,200. So it is not you have to pay full amount. So you can pay you can use the ESMC1 coupon code to get a discount of 509. So you can pay off 691 only. So it is if you pay 691 means the internship you will get the internship. you will get an internship confirmation letter. So what are the benefits are? So we are developing a code right now. Even we are developing a code for USART of DMA. So when you are practicing in the your K or your system, so if you have any doubts, means you can refer to those videos. So those videos will be accessible for 90 days when you join for the internship. So you can have those videos 30 days of live sessions. So you can use those videos for the reference. Then you will have an hands-on practice on embedded projects, and we will develop lots of projects using the STM32 controller, and you can also try it using those things. And if you have any doubts, means you can directly interact with me, and you will get these 30 days of downloadable presentations, codes. You will get these what are the codes I am developing, that the files will be given shared to you, and you will get a PPT of all these PPTs. Then you will get in a data sheets, small data sheets, referral manuals, all these. What are the stuffs we are using for this WP code? So those are all the things will be provided to you. And what is the main advantages? We will have a one-to-one 6 masterclass lives, mastermind sessions. So already today is in Saturday. Today the session is over. So I think my contents are clear. So the guys are everyone is clear. So guys, the Saturday session is already over. So batch 2 from Monday, the batch 3 is starting. So register now. So the internship link will be provided in the chat box. So you can don't waste the time. So you can click now right now and register it. So you can attend the upcoming Saturday class and you can have the access to all the records. So what is the benefit is you will after registering you will get an internship of confirmation letter, and we are going to provide 2 certificates which will be very helpful for you to add the certificate in the resumes or to give a change of domain when it to show in the interviews. So we are going to give 2 certificates. One is for course completion and another one is for participation. Okay. So guys, don't miss this chance. So use this chance to register. So our fees is 1,200. So you don't need to pay the full amount. You can use the CSMC one coupon code. So you can get the discount off. By using this, you will get a discount of 509. So the discount price is 691 only. So this is a registration link. So it will be available in the chat box. You can see the chat box, guys. So click those links to register now. So you can join as an internship user. Okay. Okay. So we will come back to the code. Okay. So first we will create a int main of function. Okay. So go we will create a int of main void. So first is we have to add the system clock. Next is I have to init the user init UART. Next is I have to init the DMA off. Next we have to send the data, right? So we are going to send the data from the memory to the peripheral, right? So for that process in STS class we have developed the DMA config. So in that we have transfer the ADC data to the buffer, to some buffers to the memory. We have stored it in the RX data. Today what we are going to do is we are going to transfer the data from the memory to peripheral, right? So for that purpose we have to send the data from the, we have to say the sources. We have to send the sources, source addresses memory, and destination as well as peripheral. So we have to say that give the data from the memory to the peripheral. So what's the first thing we have to do is in our DMA. So we will of 32. This we will send the address of the we are sending here a source address. So we are going to create a we will say we will create a data of okay. So now we have created the data in the memory. Okay. Okay. So now we have created the buffer. So here we are already have a data which is 20 and 10. So it will be in the memory. So now we will make it as an unsent of. So we will make it as an 8-bit, okay, because we can read and write the data. We are going to 8-bit. Okay. So the first thing I'm going to do is I'm going to read the data from the memory. So I will read the address of this data. Okay. So just data. This is my this is going to send my these values addresses to the source address to the my memory. So next is I have to give the value to the peripheral, right? So for that purpose, I'm going to create a 32. I'm going to send the value to the USART of 3DR. So now I'm going to send the value to the data register. Then finally I have to say the size. What is the size? We will make it as 2. Okay, 2. So our size is 2. So I will give it the size 2. So now we have created this. Then we will create a while. While we will compile it now. Before this, we will copy all this. So yeah, no errors. Okay. So guys, today we have created the code for USART using the DMA. Okay. So in next session we will implement the ADC values here, ADC code here, and we will read the ADC value and we will convert those values and store those values in the memory. Then we will take the data from the memory and we will show it in the serial monitor from memory to peripheral. Okay. So this is how the code has been developed. Okay. So guys, today's session is over. We will meet on the next session. Okay. Okay. Thank you.